Guys, welcome back to another episode of Rennch. Today we are back on the Subaru swapped Porsche and we are hitting a major milestone. So the last couple of years have served to teach me a lot of lessons. One of the primary lessons is building a product for the masses that will work for many people in many different configurations is very, very, very different than building a one-off in your garage. Having something be repeatable and manufacturable comes with a whole set of challenges, not only engineering, but implementing and making sure that the product itself is relatively bomb-proof and relatively easy to implement for whoever buys the product. Such is the case for my Subaru EZ30 swap for Porsche 911s and 912s. If you guys are new to the channel or new to the project, this kit behind me in this 1969 911 is a Subaru EZ30R that I have modified and created a lot of custom products for, so you can put it into a vintage 911 or 912. The engine itself is a Subaru Flat 6, which mimics in a much more modern fashion essentially a 3-liter Porsche SC engine. And I've gone through a lot of lengths in the last couple years to make sure when you pull into a Cars and Coffee and you have this swap, nobody even knows it. All it serves to do is be much lower maintenance, much higher horsepower at 300 horsepower, and a plug and play solution that doesn't modify the chassis at all. In fact, when the crate shows up with this engine in it, you could theoretically be driving within like 2 hours. So that is all of the work I've been doing. One of the most critical parts of the kit is making sure the engine mounts in the 911 in the factory mounting points. If you guys tuned in to my December videos, which are literally 6 months ago now, if you guys happen to have tuned in to my videos where I drove the car around the block in December, I had to make a radical shift in how I architected the cooling system, going from the front of the car to the actual engine compartment itself. The trouble was, I designed these brackets to hold the radiator, and for whatever reason, I couldn't seem to get it centered in the engine compartment. But only after stepping back did I realize the engine itself is so wonky in the engine compartment, and it's wonky because the cradle that I had built was wonky. I mean, I literally built it from my back, you know, cutting parts and welding upside down on the floor. And it was never more apparent than when I actually overlaid my scan, my 3D scan of the engine cradle with the 3D model that I had been designing, and I could see how twisted it was. So to fast forward, I have finally received all of my laser cut parts from Send Cut Send that represent literally 6 months of work on my part, having to learn 3D CAD software. I'll tell you what, who knew that the most important tools in my garage for 2025 were going to be Fusion 360 and a 3D printer? That was not on my bingo card. However, they have been absolutely instrumental in designing and implementing prototypes for this cradle. So there are 2 major pieces to this cradle, and by the way, it's still in boxes. I haven't even opened it yet because I was waiting for you guys so we could all open it together. But there's 2 major pieces that are critical in this build. Number one, I wanted this thing to assemble like one of those balsa wood dinosaurs we all had when we were kids. So it's kind of a tab and slot design. So the first thing that needed to matter was I wanted the slots to interface really well. And that's something I was able to test with my 3D printer before I sent it off to be printed in metal. The second thing was this interface, which has to bolt to the bottom of the Subaru engine, isn't just a straight cut. My engineering challenges were, A, I had to make sure that the angles were correct for the Subaru engine, but 2, I needed to make sure I could drop the cradle out without dropping the engine mount out, which was the problem I had with my hand-built one. So what I did is I implemented these little L's in here that allow the bolts, which come out this way, to drop straight down before I slot the entire thing in. So we're gonna see this together, if this all works, and we're gonna grab all the parts from Send Cut Send and make sure the metal parts perform like the plastic parts. All right guys, moment of truth. So the first thing I'm gonna check is to see if my interfaces work like the plastic one does. It's pretty cool. Cool little details. This is one of the back parts. These are the diagonals, which are these angle iron pieces. Oh, let's go. Look at that. How sick. Oh, that's cool. All right, let's open this thing up. Oh man, this is so cool. Just gonna send it. Goes on the welder for sure. And then they always give you like some cool thing. These are sour punch. Definitely gonna eat that. That worked. Come on, that's so sick looking. Look how thin. Look at that thin little guy. I don't know if I meant to make it that thin, but it doesn't matter. It's just for location. So let's see. So this goes this way. Yeah, dude. Let's go, bro. Come on, all the way down. Oh, it's so sick. Come on. Look, I got my little Rennch logo in there. Let's go. How rad. There it is. Prototype and reality. And here's the big, beefy main part. And this is gonna hold up your muffler and exhaust. These things will be threaded. Again, logo. But these things will be threaded so that I can screw the exhaust hanger in here. One thing I have to modify is that on this particular piece, which kind of connects the sides to the center, I didn't have enough overhang for send cut send to bend it, unfortunately. So all I did is I cut slots, and I'm just going to hit this with a grinder a little bit, and then I'll hammer it down and bend this thing 90 degrees, and then just lay a weld bead there, and this will be a 90-degree bend that will interface with this part. So imagine that this is slotted in, but it's 90 degrees bent, so it's this way, and it interfaces with these diagonals. Pretty sick though, man. I gotta say, that's awesome. Let me get set up and get these things bent. So this example is where having this awesome fixture table from Fireball is so amazing, because I can 90-degree clamp this piece. Since it's got the holes on the sides and the top, I can clamp it that way, making sure that this is a perfect 90-degree angle. Thanks, Fireball. There we go. Nice and cleaned up. All right, there it is, guys, in all its glory. I think it looks awesome. What do you think, Benny? So, while I move this thing over to the fixture table, I thought it might be a good opportunity to show you guys exactly how twisted and wonky the handmade version of what I did was. So, I'm gonna pop this over to the fixture table and check this out. Okay, so before I jump into the welding, I wanted to show you guys how I got to this point. So I'm gonna give you the Twitter version of 3D scanning and modeling, eventually to end up with a part that goes to send, cut, send, comes back laser cut, so we can weld it together into a nice, perfect piece. First and foremost, myself and Ian McGale. Ian runs coldwater914.com. They are a Porsche 914 specialist, and he created the original Cradle that has the wonky Subaru engine mounts at all the right angles. So if you actually have a Porsche 914 and you want to do this Subaru conversion pretty much to any engine, including the Subaru transmission and 901 and 915 transmissions, he's got a Cradle already ready to go. You can just buy it from him for 600 bucks. Anyway, he and I created this Cradle from the base of his and then welded on pieces literally on our backs under the car. So this is a scan of that Cradle with the Creality Raptor X. And here's what it looks like. Kind of cool at first glance, but when you look at it more closely, you'll see it's got some pretty major flaws. And these were flaws that did not become apparent until I was trying to create some radiator brackets, and I just couldn't seem to get the radiator centered in the engine compartment. And finally, when I stepped back, I went, wait a second, that is way skewed in the engine compartment. It is really wonky. So check this out. If I go to the front of this cradle and just click it like this so it's totally straight, you can immediately see everything is not great. Like this end on the right is higher than this end on the left. All of this will become really apparent when I show you what it is next to the 3D model. And let's go there now. So this is the engine cradle assembly as I've designed it. And this is a facsimile of what we made by hand, but this is obviously a much more developed laser cut straight version. So here it is in all its glory. It's looking pretty cool. It's got my logos all over the place. So this is the back of the cradle as I've designed it. And mind you, all of this has been done in Fusion 360. I'll show you how in a second. But look what happens when I overlay the handmade cradle with the 3D designed cradle. Holy moly, look how off it is. So we can see things are looking pretty good on the top. Pretty solid on the top. It's dead even. This is where it mounts to the Porsche chassis. And even on this left side, this diagonal looks pretty good. But holy moly, once we get to the bottom, we can see the engine mount on the right-hand side is way higher than the engine mount on the left-hand side. The diagonals are way off as well. You can see this one goes lower than this one. And then this right side diagonal, look how far it shoots out to the right here. And if I turn the thing sideways, you can just see everything is really off. No wonder the engine was sitting so weird in the engine compartment. So obviously we wanted to fix that. So what I did basically is I started with this top part. You know, I had some definite measurements from hole to hole where the Porsche engine mounts are. And I knew that I had to have a spot to mount the exhaust hanger. And then redesigned these base plates so they were able to be quickly removed. But a lot of this internal stuff is pretty similar to what he did. Everything's in 1/4" steel. And then basically designed the diagonals and connected everything together. So what you're seeing here is basically an assembly in Fusion 360. But I can show you that everything is an individual part. So here's one of the diagonals. And I had to design this individually. For instance, if I want to show you the mounting tabs for the engine, here's what they look like. And then within Fusion, all you have to do is when you're doing the assembly, you bring all of these individual things. This is considered a component in Fusion 360. You bring it all into the same drawing, and then you're able to connect things together using join commands, and it kind of magically connects all the pieces together. And then you have an exact replica of what's going to be out in the real world, which is so cool. So that's the basic explanation of how I ended up where I am. So there's nothing left to do but go out, take a few measurements, and get the thing tacked together. All right, as you guys can see, I have a very rudimentary jig set up here. I just made a run to Harbor Freight. And by the way, 40% off their Icon tools. I got this combo wrench set, 6mm to 19 with no brakes, which is why I bought it. It was 70 bucks. And these are actually really nice wrenches. I went to Harbor Freight to get some more clamps and to get some more magnets because there's a few things I can control. These interfaces are 90 degrees apart. So I can use the magnets at the top to make sure that the 90s are 90s. And then I think what I'm gonna do here is I'm gonna make my own jigging. I'm sure Fireball Tool makes the proper kind of jigs that I need to prop this end up. Right now I'm literally just like setting it on top of one of their clamps. And I've got it clamped on this end, and then I've literally got it zip tied together on each corner to make sure it doesn't unslot itself. So I think what I'm gonna do here is take this bit of square tubing, I'm gonna cut it in half so I have 90s, and then I'm gonna clamp those 90s onto these insides, and that's going to make sure that these things are exactly 90 degrees. I could theoretically do it on that side as well. I can clamp them, and then at least I know it's square. So that's the first part. The second part is making sure that the parts that are supposed to be level and level with each other are level, which I can do. This table can level, and I haven't leveled it yet, but I'm able to change the height of each wheel and make sure that the table itself is level. So then once the table's level, I can level this thing, and then all I have to really do is go back to Fusion and double check the measurements from like the base of this particular piece to the height of each corner. And as long as I get that right, then I know I'm square and it's designed the way it's supposed to. This will all make sense once I actually do it, and it's all in my head right now. So let's get to it. I didn't mean to do that. All right, so here it is in all its glory. Again, totally winging it with the fixture. This thing is just sitting on top of here. I'm sure there's some way to affix that stuff in like a proper fashion. I do not have whatever fixture that is. So what I'm doing is contemplating making something out of this where I can maybe like bolt this piece to a squared version of this that kind of mounts to the table. I don't know. What I do know though is that these are now 90 degrees. Each corner is 90 degrees. This is basically what I ended up with. And again, there's probably a fixture for that as well, but I'm going to be so OCD about making sure this thing is square and plumb and level and all the things it needs to be. And the other thing I'm sort of making a decision on right now is I was planning on TIG welding this whole thing, but I'm actually thinking that MIG is going to be a better choice, at least to tack it together. I can easily throw a bead of MIG weld on these outside corners and keep this thing basically stitched together. And then I'm going to pop into Fusion because I can take exact measurements of exactly how much distance they're supposed to be and get this thing completely dialed the way it's supposed to, like millimeter precise, before I take it out of the jig, which is ideal. Once it's all tacked together, that's kind of only part one because I need to do a couple of things. Number one, there's side pieces that will hang from the car and bolt through here. And I've got to make sure that this is located correctly on the car. This was a bit of a guesstimate where I put the slot. And then also, I'm probably going to want to eventually create some gussets in each corner and weld the gussets in, just because I like saying the word gusset, because it reminds me of being a BMX kid. So I'll have a look at my BMX spikes and go, ooh, that's a cool gusset. And then I'll just basically duplicate them and stick them on here. And then we should be pretty good and pretty square and ready to stick on a car and see how it goes. All right, I'm gonna wrap it for the day. My lady's coming home, so I'm gonna go get ready for that, and I'll see you guys tomorrow. So I have here a digital level, and when I stuck it on the cradle, I was like, uh-oh, it's a little high on this side. And then I thought, wait a second, let me test the table. So the table itself, if I stick it right in the middle, it's high on this side. Well, that was simple. It took 2 minutes to level the table. So now it's level that way and level that way. So now I just need to measure the cradle and make sure it's level that way and level that way. And we should be really close to being able to weld. 0. Yeah, 0. Well, I've made a mistake. I just realized, thankfully, before I welded this thing all together, that I've got this bracket backwards. The way I've designed this, which should be like this, means that this interface is on the bottom and it's flush. And I have a welding point here as well as on each side. And you can see if I do it the other way, I do not. I just have basically an open area and there's nothing to weld to on the inside. Annoyingly, that took about 40 minutes to reset. Of course, it completely fell apart like a house of cards. So I had to re-zip tie everything and reclamp everything and remeasure and re-level and do all the things all over again. But now I'm ready to tack a couple of key spots. Okay, I've double checked my measurements and we are all clamped. You can see I'm tacked in a bunch of spots, but now I'm like heavily clamped everywhere. And I'm gonna just start putting weld beads on all of these joints. Okay guys, next day I ran out of gas and just replaced it So it seems like we're still pretty square. Everything cooled down appropriately. There's a few welds I'm very proud of. This one being the proudest. If I can get in here. Yeah, look how good that weld is. It's lovely. I kind of figured something out on that one. Weirdly, it's in the hardest to reach spot. So maybe I just need to make these all really difficult. So next thing I have to do is get these guys welded in. They're both still loose and out. And to do that, I really need to pull up on this a little bit so I can pinch this together to where it's supposed to be. Now that's not the easiest thing to do while I'm also holding everything up. And I also want to make sure that this is level. So I'm going to see if I can figure out a way to just kind of boost this thing up a little bit with my hand or with some sort of bracing while I weld this piece here. So I'm going to do the same plan here. Basically using these vice grips, butt up against the jack, and then I'm jacking the whole thing up to the right point. I don't know what the hell happened to the weld. I just could not get it to penetrate over here. That was super annoying. All right, same drill. I'm going to let this cool, and then I'm going to actually unjig it and move it around a little bit so I can hit some of the other spots. Okay, I am fully welded up, guys, and I'm going to let this thing do its thing for a while. I do see one mistake I made. It's really hard to tell from here, but I think that I didn't let this thing settle down as far as it needs to go, so it's a teeny bit higher. Maybe not even a quarter of an inch, maybe an eighth of an inch. So I may be able to help that along with a hammer or, you know, a long crescent wrench or something like that. But I'm going to let this thing cool naturally as I did last time. I'm crossing my fingers that there's minimum warpage. Up your end a little bit. Yeah, there we go. Now come back up. Come on, work like I designed you. Work like I designed you. Oh, please work. Please work like I designed you. Tilt your end up, please. Up more. Oh, there you go. Let's go. Let's do this. A couple tweaks to this bad boy that I'm going to have to do to get it really properly installed is first I had to clearance these edges here, and that's because this thing has quite a wide outrigger on it that I didn't account for entirely. I kind of missed it a little bit. And then the other thing is I made this tolerance a little bit too tight, so it's really hard for the bolt to go through here and slide. So I'm going to have to clearance these a little bit. Where am I going to get 25 millimeters, Ben? People always ask, why is it taking so long? Well, because you run into some things that are challenges and you have to steer around them. First and foremost, my design, pardon me, Ben, if you wouldn't mind. My design here worked great. I was able to get the cradle right on and slide it forward in the mounts. So that's perfect. I clearanced it just a little bit, as you just saw. And now this is fully slid up and all the way forward. On my handmade cradle, these outriggers, I'm calling them, actually angled that way a little bit. They weren't fully straight, like 90 degrees like these are. They had a little bit of angle to them. In fact, they had 25 millimeters of angle forward. And that accounted for this cradle being the proper spacing here. You see, I can fit like one hand barely. There's an extra 25 millimeters here that I need to figure out how to build into this cradle. Well, sadly, that's going to kill the rest of this video. All right, guys, so I have just spent an inordinate amount of time creating these two gussets. And what they're meant to do is two things. Number one, they are meant to locate the correct angle here. They're totally identical. I made them exactly the same. They are to complement the 80-degree angle of these outriggers. And what I'm going to do here is these bad boys go right here. So not only do they ensure that the angle is exactly the same on each side so I don't get a little out of whack, but obviously they strengthen this area, which to me was looking quite weak. Another quick shout out to Fireball for the table. Clearly I'm obsessed with trying to make sure these things are symmetrical. You know, in the perfect world, and the next time I do this, this will all be laser cut. I will not have this piece in here. But the crux of this is that without this fixturing, it would be really hard for me to make sure that these things were clamped. This way I can literally just take a Sharpie and mark this thing and cut this thing exactly the same on each side and make sure we are good to go. I mean, look at all the pomp and circumstance I have using this fixture table. So once again, thank you Fireball for this awesomeness. All right guys, so that was a very successful endeavor. I added exactly 40 millimeters to the length, really this space between here and here, which meant that it fits fantastic in the car itself. So now I've got to worry about welding it all together. And what I've decided to do is I'm actually going to weld the inside corners with my MIG welder. And I'm going to do that because I really want to add gussets to each corner before I weld the rest of it. I want to make sure I keep it exactly square as it is. And then I'm going to do my best to TIG weld the entire rest of the cradle. And I want to do that for a couple reasons. Number one, I really want the TIG practice. This is a perfect opportunity. It's really thick metal. It's got much less chance of, you know, burning through and that kind of thing. So I want to do that, and I think it will look better, in theory, if my TIG welds look better. All right, dudes, so the gussets are all welded. I'm very happy with my welds here, coming right along. Some are really good, others aren't so great. It really has everything to do with how much you can brace your hand and how smooth you can make it. Like this was really good. Then I had to fill in a little hole here, but this whole thing looked like that, so I was pretty happy. This was the last one I did, actually. I've got basically 25 seams I have to weld on this cradle. And these are the kinds of things I'm counting as a seam. So it's like 1, 2, 3, and then 4, 5, 6, 7, 8, and I just go all the way around till 25. I've got quite a bit of welding in my future. And it's very awkward, so I'm going to have to just basically move this thing all over the place to try to get to each seam. So I'm going to disappear for a couple of hours and get to welding, and I'll be back for you guys in just a moment. So I'm down to my last 2 welds here, which are just on the inside. And I have to say, this fixture table is one of those things that I never knew I needed until I had one. And I don't even have all the fixtures for it, but what I've just done here, welding all these 25 seams, I don't want to say it's impossible because I've been building cars here for years. But this made it so much easier for positioning and just making sure things were clamped down. Even when I'm cutting something off or grinding and I can clamp it to the table and make sure it doesn't move while I cut these really precise corners like I had to do for the gussets, it's just so much better. So I want to plug these guys, Rennch.com/fireball, Rennch.com/fireball. Jump onto the site. This Dragon Wagon is like the larger version, but there's a smaller version of this as well. And I can't say enough. Like, it to me has been the star of this video. It's going to be the star of many other videos, I think. And once I figure out how to properly fixture this so that I can fully weld it and not have to worry about anything moving and everything being level and where it's supposed to be, it's gonna be next level. Let me weld these two bad boys together, and God forbid, we're gonna install this sucker in the car. Thrillingly, after hours and hours and hours of welding and fabrication and planning, the cradle's done. It is ready to be bolted into this here engine compartment, which presents a whole nother set of challenges. How to hold the engine up and remove this cradle while installing the other cradle is going to be a bit of a challenge. So very, very close. The cradle needs to shift another inch forward from where I had it. So I moved the whole thing about 40 millimeters. It really needed about 55 millimeters. So that just means I need to change the angle of those outriggers, however many more degrees that is, to get a little more forward. Not the biggest deal. We are prototyping, but to try to make this one work, when I pull it off, I may end up adding a little more material here on the back side and then just extend. Well guys, I changed my mind. I'm not going down without a fight on this one. I literally got done filming yesterday and jumped in the shower, and then I had this idea in the shower, which is a place where a lot of people have great ideas. Here's what I'm gonna do. I'm going to cut the mounting plate right here, and I'm gonna shift it back an inch. So once again, the fireball table to the rescue. I've got this thing kind of clamped and jigged up so I can cut it without having to worry about the whole thing moving around on me. It's so important that I get this cut completely straight. And what I've done here is just used a square to obviously line it up. And because I want to make this thing duplicatable, I'm just lining the square up with the edge of this hole so I can make the exact same cut on the other side. All right, so here's the cut spot. Really good, super clean cut, really straight. So I'm gonna move it back like that-ish. I've got some things to deal with. It's gonna cut through my logo, which is sad, unless I do something else. And I'm gonna have to figure out this kind of interference here a little bit. So I may end up having to notch this out a little, I'm not sure, but we'll see how that all goes. Okay guys, so overall I'm very happy with how the cradle works and how it looks. I've had to do a couple of things to get it to accommodate the car. Like right here, for instance, I had to grind these tabs down. So I'm gonna have to redesign the interface between how this main cross member interfaces with the diagonals. One properly rookie mistake I made was not measuring the distance between the engine mount bolts here actually on the motor mount to the Porsche motor mounts. Like this distance right here, I didn't actually measure. Had I measured it, I would have had a set number in which to make this cross brace, and it all would have worked out a little bit better. So I'm gonna need to do that for the next iteration so I can make sure I'm a little bit more millimeter precise. And in the design of these diagonals, I'm gonna have to notch these and or make this thing go a little wider to the outside before it drops in. So that's also another option, is having a slight diagonal out before it connects back in. But overall, really, really happy with how it turned out. Here's my modification. So you can see the actual engine mounting plate is still loose. and I just need to push the engine up like this, and I can tack it together. And that will give me a little bit of back and forth wiggle room. Now I got to fix a few things and get back to work. All right, I've got these tacked in a couple of spots, and I'm going to give this a quick little fit, make sure that it's good, and if it is, I will fully weld and probably put some kind of triangle piece in here. But unfortunately, I will lose my logo, sadly. So that was Cradle Adventure Part 1. A couple of things I'm really pleased about. My spacing on the cross member is really good. Again, I think the biggest mistake I made in this whole video was completely welding it before I really checked it out on the car. Lesson learned, I will tack it next time. I could have made all of these changes really, really easily had I not completely welded the thing up. I could have just made a few little tweaks to it. So, lesson learned. Anyway, thank you guys for watching. As always, I really appreciate your support of the channel. If you can, pop on over to Fireball Tool. Check out their amazing Dragon wagons. This whole process would have been so much worse with the old thing that I had, like just some regular old table. Trying to get all this stuff clamped up while I tried to weld it and make it symmetrical would have been impossible. So check out Fireball Tool, Rennch.com/Fireball if you want to check them out right now. And that's it. We'll see you guys next time.